This video on the factor and remainder theorem is a worked solution of the WJEC C1 May examination from 2007. There's the question. So at first we remind ourselves, what is the remainder theorem? The remainder theorem says that when a polynomial function, just like the one above, is divided by the expression x minus a, well, we're going to see that in part C, then the resulting remainder is f of a. Well, that sorts out what we're going to do in part C. Let's remind ourselves what the factor theorem says. This is just an extension of the remainder theorem, and it states that if x minus a is a factor of the polynomial, then obviously x minus a will divide exactly with no remainder, which can be stated the other way round, that if f of a equals 0, then x minus a will be a factor of the polynomial function. We can use this in order to factorize cubic expressions and hence solve cubic equations. So part A told us that we were given x minus 3 is a factor of this particular polynomial cubic function, and we need to show that p equals 24. So we define our function f of x. It's always a good idea to give it a name, as x cubed minus 5x squared minus 2x plus p, and we're told that the factor x minus 3 exists. We apply the factor theorem here. We say that f of 3, notice the sign change, minus 3, substitute a 3, f of 3 must equal 0 because x minus 3 is a factor. Substituting 3 into our function, 3 cubed, 5 times 3 squared, 2 times 3, then this allows us to work out the value of p as 24. We could say QED here. We've proven what we wish to prove. Part B asks us to solve a cubic equation. So as in any solving equation, we need to factorize and hence split the factors into 3 linear factors in this case. In order to factorize, we need to apply a process of algebraic long division. There is another method, but we won't be looking at it in this video. So we want to divide x minus 3 into our cubic expression. So the process is, ask yourself, how many times does x divide into x cubed divides x squared? We now need to multiply back x squared by x and x squared by minus 3, and then subtract to work out the remainder. X cubes, subtract to 0, 5x squared minus 5x squared, subtract minus 3x squared, is minus 2x squared. Next, we bring down the next term, that's the minus 2x, and again repeat the process. How many times does x divide into minus 2x squared? We say minus 2x, and multiply back minus 2x by x minus 3 to give you minus 2x squared plus 6x. Subtract, find the remainder. Minus 2x minus 6x is minus 8x, and bring down the plus 24. Repeat the process. How many times does x minus 3 divide into minus 8x? Minus 8 times. Multiply back, minus 8x plus 24, and thankfully we have a remainder of 0. This confirms, of course, that x minus 3 is a factor of the function as we were told. So now we can split our cubic function into a product of x minus 3, that's what we divided by the quadratic function, which, if you remember, was the answer to the division. The quadratic in this case will factorize further. Using standard GCSE skills, we can factorize into 2 linear factors. We now have an expression which is fully factorized. Don't forget, this is not the end of the question, because we wished to actually solve the cubic equation equals 0. And now that we have the factorized cubic, then we can split the 3 factors each into 0. X equals 3, x equals 4, x equals minus 2, coming from x minus 3 equals 0, x minus 4 equals 0, x plus 2 equals 0. Part B is done. The last part is the quickest. We have the remainder theorem. If we remind ourselves that when the polynomial function is divided by the expression x minus a, then the resulting remainder is f of a. So this time we need to divide by x minus 2, and so we substitute plus 2 into our function. F of 2 is 2 cubed minus 5 lots of 2 squared minus 2 lots of 2 plus 24. Working out each part gives us a remainder of 8. A nice simple